All right, hello. So on Monday we were talking about equivalent resistance of a series circuit or a parallel circuit, but there are some circuits that we might call complex circuits that are combination. They have series parts and parallel parts, and so I want to talk today about how to handle those. This paper that I've got in front of me, I've got it posted. You can download it if you'd like. If you'd like to print it and follow along with me, you can. If you just want to see it, if you just want to watch what I'm doing, it's fine. I'm not collecting this or anything. It was helpful to have the circuits pre-drawn, so that's why I printed this out. But I posted that if you find it helpful. But basically, I want to take a look at this, and remember we've got two equations, right? Whenever we have a series circuit, we find the equivalent resistance by just doing a simple addition of all the resistors. But if we have a parallel circuit, we have to do a more complicated calculation where we add the inverses. Okay, so what happens if we got a combination series and parallel circuit? And here's an example, right? So if you think about the current coming out of this battery, what's it going to do? Well, all the current has to go through the 2 ohm resistor, right? But then it splits up, and some of the current goes here and some of the current goes here. And then all of it goes through the 3 ohm resistor. So what we could say is that these two are series elements in the circuit, but these two are parallel because the electricity doesn't have to go through both of them. It only has to go through one of them. So what we're going to do is we're going to break this down into an equivalent circuit. So what I can say is I know that this part here is a parallel circuit. So I'm going to treat just this part, not everything, but just this part as a parallel. So I should be able to say that 1 over the equivalent resistance of this part should be equal to 1/5 plus 1/3, which comes out to be what? 3/15 plus 5/15, so 8/15, I think. I really hope that I'm right because there's no one in front of me to correct me. I'm pretty sure I'm right. So then I got to take the reciprocal, right? So 15 divided by 8, the equivalent resistance is 1.87588 ohms, right? What does that mean? That means the reason we call it equivalent resistance is because this circuit is exactly equivalent, at least in terms of calculating the current, to this one, right? So I'm going to put my 2 ohm resistor and my 3 ohm resistor just like they were here, but I'm going to replace these two with one resistor that is 1.88 ohms. Now I have a simple series circuit and I can just add them together, right? So I can do, for this circuit, the equivalent resistance is 2 plus 1.88 plus 3, so that's 6.88 ohms. So that's how we do that on this one. Okay? I'm going to try number 2 with you. What about this circuit? Now you got to be careful because a lot of people are good at recognizing that there's a parallel element here, but one thing you cannot do is you cannot do 1/10 plus 1/8 plus 1 over 2, right? Do you see why? The reason why is because even though this is a parallel circuit, inside this parallel circuit right there, that's a series circuit because any charge that goes through this resistor has to go through that resistor as well. So I start by treating this as a series circuit where I do 8 plus 2, which is 10 ohms, right? And then I'm going in tedious detail. You don't necessarily have to redraw your diagram every time, but I'm just going to kind of go in tedious detail so that you understand that that's supposed to be 5 ohms, 40 volts, just like this one. But over here, this 10 ohm one we didn't touch, but we replaced the 8 and the 2 ohm with a single resistor that's 10 ohms, right? And now you should see the next thing we do is we have another parallel here. So we got 1/10, 1 over REQ equals 1/10 plus 1/10. 1/10 with 1/10 is 2/10 or 1/5. So 1 over REQ is 1/5, which means that REQ is 5 ohms, right? And now what I can say is that I've got a circuit that has the 5 ohms here And my handwriting is terrible, I apologize. And this equivalent resistance is now 5 ohms. So now I have, jeez, I can't draw. All right, so I'm getting ahead of myself. So this is a series circuit. I just add those. So the total equivalent resistance of this circuit is 10 ohms. And then if you actually read the problem, it asks us to calculate the current. So then I can go back and I can say V equals IR. So the voltage is 40 equals the current times 10. So that's going to be 4 amps of voltage of current. Honestly, that's as complicated as we're going to get, unless you go to the bonus assignment that I'm going to give you next week, where we would have a complicated circuit. But if you're good, feel free to stop the video here. I'm going to do one more for those of you who'd like to stay, but if not, you can go ahead and go on to the check for understanding. This should be enough. Okay, so let's look at this. So this is a fairly complicated circuit. So you'll notice I got 2 in series, then I have 2 in parallel, I have another in series, and then I have a parallel where I got series and parallel. So what I'm going to do is I'm going to combine the ones I know. I know that these 2 are series, so they're just going to add like regular, so that's going to be 3.5 if I just add those together, right? I also know that these 2 are in series, they're going to add together, so I think that's going to be 1.75. All right, so now I'm going to go ahead and redraw. So it's like I have a 3.5 ohm one there, and then I guess while I'm at it, why don't I do this one, because I should be able to do that one. So 1 over REQ equals 1 over 3 plus 1 over 3/4, which is 4/3, right? So that's 5/3 or 3/5, which should be 0.6. So the equivalent resistance of this should be 0.6 ohms. Okay, then I've got my 1 ohm there, and I've got a parallel down here with 2 ohms and 1.75 ohms. So this is my first step at simplifying this, right? Then I'm going to say now I know all of those are series. So they add up to 4.5, 5.1, I think. Yep, I think that's right. Okay, and then this one is going to be 1 over REQ is 1 over 2 plus 1 over 1.75. 1.75 is what? 7/4? Did I do that right? Yep, 7/4. So 1 over 1.75 is going to be 4/7. That's going to be ugly. So that's what? 7/14 plus 8/14, which is 15/14. So REQ is going to be 14/15, which I'm getting to be 0.93 ohms, right? And you should see, I'm not going to redraw the whole thing again. You should see this is just one simple circuit now. It's got 5.1 ohms and 0.93 ohms. So I should just be able to add those together and get a total equivalent resistance of about 6 ohms. It's actually 6.03 ohms, but okay. Yes, please feel free to ask me questions about this. If you have any questions on the math, I'm happy to do a individual Zoom meeting with you, or as usual, 1 o'clock on Wednesdays, I have scheduled office hours on Zoom. So just let me know. Have a good day.